Imagine stepping out the back door of a bright house into a moonless, pitch-black night. For those first few moments, you are completely, helplessly blind. But if you stand there in the dark for 45 minutes, your vision transforms. You go from stumbling over the porch steps to being able to discern the faint, scattered light of distant stars. This logarithmic scale shows the sheer range of human sight. Our eyes operate across 9 orders of magnitude, meaning the brightest sunlight we can process is roughly 1 billion times brighter than the dimmest starlight. The eye cannot process that entire billion-to-1 spectrum all at once. Instead, it relies on 2 distinct visual systems that share the same space but cannot operate at peak efficiency at the same time. Seeing in the dark requires a mandatory waiting period for your daylight-focused biology to shut down and for a highly sensitive night vision system to finish a lengthy boot-up sequence. In the first 60 seconds of darkness, your eye attempts a mechanical fix. The pupil rapidly expands, acting like a camera aperture to let in as much ambient light as possible. This mechanical response is physically insufficient for seeing in true darkness. Widening the opening only gathers available light. It does nothing to change the retina's chemical sensitivity. Between minutes 1 and 10, 5 million cone cells in your fovea try to adapt to the fading light. These are the receptors responsible for high-resolution color in bright environments. Cone cells are strictly designed for high luminescence settings. Their sensitivity caps out after 10 minutes, rendering them useless in deep shadow. During this handoff, you enter the mesosopic range. This is a twilight transition phase, where the daylight system is fading and the night system is waking up, causing them to briefly overlap. This transition triggers the Purkinje shift, where your peak visual sensitivity moves away from warm colors and toward the blue and green end of the spectrum, around 500 nanometers. In practice, this changes your world. Red objects like flower petals appear pitch black, while green leaves and blue accents look unusually luminous. During this twilight phase, the human eye is literally changing its biological color filter to survive the fading light. From 10 minutes to 2 hours, the retina's heavy hitters take over. 100 million rod cells finally activate to provide true scotopic, or night, vision. These cells face a chemical bottleneck. They rely entirely on a single light-sensitive pigment called rhodopsin. In bright light, rhodopsin is bleached out. It is actively destroyed by the sun. This leaves your rods completely blind the moment you step into the dark. Rebuilding those stores takes time. Your body requires up to 2 hours in the dark to chemically regenerate rhodopsin from vitamin A. This chart outlines the phototransduction cascade. A single photon activates rhodopsin, converting it to metarhodopsin 2. This activates transducin and the enzyme phosphodiesterase. Finally, the enzyme hydrolyzes cGMP, closing sodium channels and creating an electrical charge that fires a signal to the brain. This microscopic chemical factory is the sole reason our rods can boost their sensitivity 1 million times higher than their daylight baseline. At the 2-hour mark, the timeline is complete. Your eyes are now fully dark adapted and operating at maximum sensitivity. To maintain this sensitivity, your biology makes a trade-off. Multiple rod cells must pool their faint signals together into a single neural pathway to amplify the message of light. This pooling mechanism costs us our resolution. By combining the data of many rods into one signal, we sacrifice fine detail and color, resulting in a blurry, monochrome view of the world. Night vision functions as a specialized, ancient survival system, a biological backup that prioritizes detecting the presence of light over discerning its detail. The next time you find yourself stumbling in the dark, give it time. Your retina is quietly regenerating the molecules required to translate the hidden details of the night into focus.